Everything we do on this YouTube channel eventually available on this website. So default is all tools selected, but then want to focus on one of those EEG or ECG, so neurology or cardiovascular stuff. Okay, just before we start, a quick thank you note to contributors. Yes, we have supporters on Patreon and YouTube. We have Johan, Matthias, Majnoon, Ibtesum, Salim Huda, Andrew Stevens, Cody, Aston. So thank you for your support. It helps to continue the development of those tools that hopefully democratize biomedical data processing. Here I have a bunch of stuff. This blog on cochlear implants. Yeah, the site is currently large because it has some data published on it as well, which yeah, ideally would just place on the CD and I'll get rid of. It's nice and quick when the data is close nearby to the code. Trying to do everything in JavaScript, by the way. Only rarely we require Python backend. Ideally not. Well, because we'll save electricity. But yes, essentially the more patrons we have, the more complicated stuff we can do. Yeah, about 5 GB of data is cached on the site and 10 GB is being served. Let's actually see the about. Yep. So the about section now includes the supporters here. If you would like to support, you can do it both on Patreon or YouTube. On Patreon you can see the videos with no ads. Right, and we have this Python script that's actually checking the site. Can we have all up? 98 things that we need to fix. PC only works with camera from memory. Again, games are handy because you can test straight away if things are working or not. Issues with Plotly version. It essentially says do not use Plotly latest. We're using it in the ECG feature extractor as well. It's still working though. Still warning. This warning, which is an error that is not being picked up by a Python script, which is a bit odd. We have another ECG signal generator. Synthetic, obviously. You can export your signals. It does a PNG with no background or CSV, so that's handy. This should have all the electrodes. 1 to 3, AVR, AVL, AVF, V1 and 2, V6. So that's nice. So both exporting works. And then you have basic presets. Normal is 70 BMP, 3 leads. You have the export functions. We really need an expert to check this for us as well. This Mobitz settings will be only relevant to AV blocking 2nd degree. There should be also Mobitz 2 as well as 1. But yeah, from memory we didn't do it because it's getting way too complicated. It seemed to work. Obviously needs more testing. The waveforms could be made larger. I was about to get rid of this one because it's not working correctly until I realized there's this JavaScript. It's actually quite useful, if correct, of course, where we have the ID, the type of arrhythmia. So we have sinus tachycardia, AV block, and then there is a description. It's kind of nice. Should ideally combine it with the ECG generator. This is the third version of it. Right, and this has this presets, which is actually more useful, isn't it? It's more practical. Could use a description there as well. Yeah, I want to do a deep research on this one. Just curious what will happen. We just paste this JSON file and do a deep research on that. Should ask us questions before progressing.
Could you clarify what you'd like me to do with this ECG data? Are you looking for an analysis, visualization, classification model, or something?
Okay, we can't change the original prompt. We would like a description. We would like to add a description setting, a description entry to this JSON. So this is a JSON data file. And we need a deep research seeing if these metrics, these settings are correct. And we also want to see what's missing, because we have, for example, first AVB, is there second and third. So we need a deep research on this. Take your time.
I will conduct in-depth research to verify the accuracy and completeness of the ECG rhythm parameters in your JSON doll structure. This includes confirming the correctness of each rhythm's metrics, for example BPM, PR interval, QT interval, QRS duration, SD offset, RRSD, identifying any discrepancies or missing features, and ensuring consistency across the different arrhythmias such as AV blocks, tachyarrhythmias, and myocardial infarction. I'll also include suggested values for any missing conditions and provide a concise but medically accurate description field for each entry. I'll get started and notify you as soon as the findings are ready for review.
Still thinking about, but we could interior review how it's conducting its research.
I'm thinking through the ECG metrics for each rhythm, ensuring they fall within accepted ranges and identifying any inconsistencies or missing arrhythmia. I'm pulling together typical ECG parameter ranges for normal sinus rhythm, brady, tachycardia, and specific arrhythmias like atrial fibrillation, AFib, and STEMI from trusted guidelines and sources.
You could actually use deep research on each one of those.
I'm working through the PR interval, QRS width, and QT interval values for normal ECG durations. This could serve as a reference point. I'm evaluating each rhythm for accurate metrics, highlighting missing arrhythmias and potential errors, consulting reliable sources to ensure precision.
It's good it went for an actual reliable source, yes.
Okay, let me see. Sinus Bradycardia is a slow heartbeat below 60 BPM. So, I'll look up the normal PR and QRS intervals to confirm. I'm analyzing ECG characteristics of sinus bradycardia, ensuring the PR and QRS values align with standard norms, highlighting any discrepancies. The LIFL guidelines provide a thorough outline for assessing the EKG rhythm, including the regularity of rhythm, rate between 60-100 BPM, and normal P waves with a constant PR interval.
Okay, assuming these sources are legit, thank you very much.
I'm noting definitions for normal sinus rhythm, sinus bradycardia, atrial flutter, atrial fibrillation, and junctional escape rhythm, focusing on their ECG characteristics.
I thought it will be doing like one at a time, but no, it's going for all of them.
I'm thinking about how blocking NCBI might affect access to necessary data, suggesting a need for alternative solutions.
I didn't get that.
I'm gathering information on AFib from sources like Life in the Fast Lane or Up to Date, focusing on typical ECG P waves and retrograde characteristics.
So did NCBI blocked access? Did it?
Litful blog AFib for 2 might explore recent AFib trends and insights, expanding upon AFib concepts. I'm pulling together insights on AFib and STEMI from medical guidelines, focusing on ECG characteristics and criteria for accurate diagnosis. I'm considering that the result likely refers to a STEP Pearl's entry on acute STEMI and CBI, which is probably a comprehensive resource on recent research findings. Piecing together the 2013 ACT/AHA STEMI guideline and its 2017 update for accurate SD elevation threshold. The ACC/AHA STEMI definition involves SD segment elevations on ECG in 2 contiguous leads, with specific cutoffs for V2, V3, and reciprocal SD depression. I'm focusing on hallmark SD elevation for STEMI, which suggests transmural infarction, and I'm noting reciprocal SD depression and progression to T-wave inversions, and I'm outlining the main criteria for identifying STEMI, mentioning the importance of SD elevation in contiguous leads and the evolution of Q waves. Additionally, I'm highlighting critical arrhythmias such as second-degree AV block, Mobitz II, junctional rhythm, and multifocal atrial tachycardia, laying out MAT, HR over 100 BPM, irregular P waves, multiple atrial sources. This irregular pattern and the varied P wave morphologies are key indicators. Thinking through second-degree AV blocks, distinguishing between Mobitz I and Mobitz II. Mobitz II features a fixed PR interval and can progress to a complete block, while Mobitz I gradually increases the PR interval until a beat is drawn. I'm detailing key arrhythmias, atrial flutter, Mobitz II block, junctional rhythm, MAT, ventricular tachycardia, Torsades de points, ventricular fibrillation, and Asystole. Litful is reliable for quick info, though not peer-reviewed or a guideline. BT, with widened QRS 0.14s and a rate of 100-280 ppm, is described as life-threatening. Taking a closer look at second-degree AV block, Mobitz II, atrial flutter, AFib, MAT, VT, UF. Sinus tachycardia seems redundant, but I'll keep it in. I'm thinking through the Mobitz field. It might need splitting into Mobitz I and II to clarify clinical differences, aligning with dataset examples. I'm refining values for STEMI and AFib, tweaking PR intervals, setting QRS durations, pegging QT intervals, and confirming SD offsets, ensuring accuracy with clinical guidelines and references for each arrhythmia. I'm validating the ECG rhythm dataset, correcting inconsistencies, and refining headings. This leads me to the next steps in standardizing the data. Searched for QT interval heart rate relationship. I'm identifying missing arrhythmias, inconsistencies, and corrections. This involves ECG interpretation, arrhythmia patterns, and normative ECG intervals, progressing through detailed assessments to ensure clarity and accuracy. I'm piecing together the idea that the QT interval stretches at slower heart rates but shrinks at faster ones. I'm digging into the sinus rhythm and bradycardia definitions, aligning them with precise source details to ensure comprehensive coverage. I'm thinking of linking to 40L50L53 for sinus bradycardia, noting it's less than 60 ppm. Searched for P wave before every QRS bradycardia. I'm confirming references are valid, consistently numbered, and integrated correctly throughout the ECG rhythm dataset and summary. I'm realizing that certain references, like 39 and 41, are actually search results, not authoritative content. I'm focusing on pinpointing direct sources, especially avoiding search results citations for academic I'm swapping out the search snippet with the actual RSM content to ensure accuracy in the bradycardia description. Next, I'll tackle the QT interval search for heart rate effect on QT interval. ChatGPT. I'm piecing together which source to use. The JAMA article stands out for its credibility, but the manual appears quite comprehensive. Considering the relationship between heart rate and QT interval I reviewed 44 definitions, confirming it covers Sinus Bradycardia, Junctional, and Mobitz II. Adjustments completed for accurate citation. I'm digging into the answer text, honing in on the numbers 41 and 39. This approach is leading me to the right intricacies. I'm ensuring accurate formatting and consistent citation of sources. Mention in type Roman 2 Mobitz might be critical, and assuming complete heart block is included due to complete AVB flag. Medically appropriate ranges. The values for each rhythm have been checked and adjusted to fall within medically accepted ranges. For example, normal sinus rhythm is correctly shown with a rate between 60-100 BPM, PR interval 120-200 ms, and QRS duration 120 ms. Sinus bradycardia is appropriately defined by a heart rate 60 BPM while maintaining the same 1:1 relationship of P waves to QRS complexes and a consistent PR interval. Atrial fibrillation displays an irregular ventricular rate with no measurable PR interval since there are no discrete P waves. And it is depicted as a rapid, regular narrow complex tachycardia with typically hidden P waves, no visible P before the QRS. The STEMI entry reflects sinus rhythm with significant SD segment elevation 3 mn, meeting the criterion of greater or equal to 1-2 mm SD elevation in contiguous leads for diagnosis. All these values and features align with standard ECG characteristics for the respective condition. Identified inconsistencies and corrections. Several unrealistic or inconsistent values from the original dataset have been corrected. Notably, the atrial fibrillation and AFib entries had a PR interval listed. This has been set to null, not applicable because in AF there are no regular P waves to define a PR interval.
There's a couple of things, yeah, it's corrected. So it's only was able to confirm 5 out of whatever we have conditions, ECG abnormalities. And the problem is, yeah, in the atrial fibrillation, we have an PR distance, well, meant to be, it says null, but it's actually not taking that into account at the moment. If we change it to 0, it's actually, well, correctly looks as if the P wave is not present, which is accurate. We can make it, or we can make it a small number. Yeah, the nulls are currently not being considered. No, I mean they are. If that value is null, then the default value from the normal ECG is being selected, which is a problem. Actually, like, yeah, if it's totally not meant to be there, the P wave, then we can have a PR timing set to 0. Which we kind of have to do, because if it's null, the default, we set the noise to be off. Yeah, so this have essentially no P wave. I can't really say it's currently an expert in this thing, even though we did this deep research. To add the description as well.
Great, I've loaded your updated JSON as a structured dataset. I'll now begin incorporating the verified and enriched entries, including medically accurate descriptions and flag consistency. Would you also like me to include new rhythm types like Mobitz II, junctional rhythm, or multifocal atrial tachycardia?
In the canvas, can we add the description for each item? Okay, what am I supposed to do in the PVC rate?
All entries in the JSON now include a description field with concise, medically accurate explanations for each rhythm. Let me know if you'd like to add additional conditions like Mobitz II or junctional rhythm, or further refine any description.
But comments are not allowed in the JSON file. What's up with that? Okay, and can we also correct the entries for which you found more accurate information? Correct them directly in the canvas based on the deep research that you conducted. And it update the BPM for atrial fibrillation. That's more like it. Yeah, those numbers are pretty much the same. Yeah, that's a significant difference here. There was a mistake there. Yeah, a few other mistakes.
The dataset has been updated with corrected values based on the deep research findings, including heart rate, PR interval, QT duration, QRS width, and rhythm variability for each entry. Let me know if you'd like to continue by adding missing arrhythmias like Mobitz II, junctional rhythm, or MAT. The entries for Mobitz II, junctional rhythm, and multifocal atrial tachycardia, MAT, have been added with accurate clinical parameters and descriptions. Let me know if you'd like to include any other arrhythmias or waveform variants.
I'll have to keep checking if those are correct. Can we check that all of these entries are correct based on current literature and clinical practice. And I'm not sure if we should do another deep research or go all three. Let's actually try all three. Should be doing research. It should be browsing. Would not imagine all of this stuff to be in its training set.
The user asks for a review of clinical entries to ensure they align with current literature and standards. I'll check if any corrections are needed, especially for QT intervals. The values might not need major changes since clinical guidelines have been stable. For QT prolongation, I know that a normal QTC is usually under 440 ms, and for Torsades, it's closer to 500 ms. I'll summarize.
Do I have everything mostly correct?
Ventricular 150 BPM fits 2:1 block. Consider adding field flutter rate, 300 BPM atrial for clarity.
If we add it, then the code is not necessarily taking it into account, does it? Yeah, the code won't be taking it into account.
Baseline PR 160 ms is fine, but Wenkeba cycles usually start with a normal PR then prolong. Keeping PR field is optional. No change is needed if this represents the first conducted beat.
Yeah, I'm not sure this is correct. Okay, we'll have to continue this next time. The descriptions seem to be correct. Anyway, anything we do like this new ECG waveform generator, synthetic waveform generator will appear. Well, it's already is on the website. Here I'll include link on the landing page and include the titles and everything, and go from there. And I'll see you next time. Don't forget to check the website. Don't forget to check out Patreon page if you want the videos without any ads. They should be there, and I'll see you next time. Bye.